Let's talk about something that's so fundamental to being human, and let's be honest, so frustrating sometimes. I'm talking about memory. I mean, how is it that you can remember every single lyric to a song from 20 years ago, but you forget why you just walked into the kitchen? It's wild, right? Well, today, we're going to try to unlock the science behind why our brains remember, and maybe more importantly, why they forget.
Oh, we have all been there. That super awkward moment when you realize the name you just heard has completely vanished. But here's the thing. You probably didn't forget it at all. See, psychologists say this is usually because you failed to even form a memory in the first place. You were so busy thinking about what to say or making a good impression, your brain never actually encoded their name to be stored. It just went in one ear and right out the other.
So, to really get why our brains sometimes fail to hit record, we gotta look at how memory actually works. It's not just one thing that happens. It's actually a dynamic, three-step process that our brain follows for pretty much everything we learn. So, let's break that down.
Think about it like this, okay? First, there's encoding. That's just getting the information into your brain, the input. Then you've got storage, which is, the process of holding on to it. And finally, there's retrieval. That's the act of getting that information back out when you need it. So if there's a failure at any one of those stages, well, the memory is lost.
A really helpful way to think about our memory system is to compare it to a computer. We have this kind of temporary memory, a lot like a computer's RAM, that holds whatever we're actively working on. And then we have our permanent memory, which is kind of like the hard drive for all that long-term storage.
So, keeping that computer idea in mind, let's actually follow the journey of a single piece of information. We'll see how it goes from the moment it enters our senses all the way to becoming a lasting memory, or, getting forgotten along the way. Okay, so this diagram you're looking at, this is the famous stage model from Atkinson and Schifrin, and it's basically our roadmap for this whole journey. You can see how information flows through three different systems. See the path? From sensory input on the left, then through short-term memory in the middle, and finally over to long-term memory. Let's take a look at each of those stops, one by one. So everything you see, hear, and feel, it first sits your sensory memory. Now this thing has a massive capacity, but it's unbelievably fleeting. Like think about waving a sparkler around in the dark. The reason you see that continuous circle of light, even though the sparkler is just one little point, is that your sensory memory is holding onto the image for just a fraction of a second. Now, if you actually pay attention to that sensory input, it gets promoted. It moves right here to your short-term memory. You can think of this as your brain's workbench, but it's got a really limited capacity, and it only holds on to information for about 20 to 30 seconds. The only way you can keep it there any longer is through rehearsal. That thing you do when you repeat a phone number over and over until you can find a pen to write it down. And finally, if that information is important enough, it makes the big leap into long-term memory. This is the brain's hard drive. It's this seemingly unlimited, super durable storehouse where memories can literally last a lifetime. But how that information gets organized in there is just as fascinating as how it gets there in the first place.
All right, time for a little experiment to see just how that organization works. I want you to take a quick look at this picture of an office. I'll give you a few seconds. Just try to soak in as many details as you possibly can.
Okay, picture's gone. Quick, what did you see? A desk, right? A chair? A computer? How about books? Did you see any books? Most people, when you ask them, they confidently say, oh yeah, for sure, there were books. But if we look at the picture again, there are no books. So why did your brain just add them in? Well, the answer is a concept called a schema. A schema is kind of like a mental blueprint. You have a schema for office, right? And that blueprint in your head usually includes books. So when you try to recall the image, your brain does you a little favor and fills in the blanks with stuff that should be there based on all your past experiences. And this is a brilliant example of how our memories are not perfect recordings. They're actually reconstructions that can be influenced and even distorted. So we've seen how memories get made and organized. But now let's pivot to the other side of that coin, the kind of shocking reality of just how quickly those same memories can totally disappear. Way back in the 1880s, there was this psychologist Hermann Ebbinghaus who did this groundbreaking and probably super tedious experiment. He memorized thousands of lists of complete nonsense syllables, things like bath and XOF, and then he meticulously tracked how long he could remember them. And the result was this famous graph, the forgetting curve. And just look at that drop-off. What he found was just astonishing. Ebbinghaus forgot more than 60% of the syllables he had just learned in less than 9 hours. That's the really crucial point here. Most of our forgetting happens super fast right after we learn something. So what's the practical takeaway? Well, he also found the key to fighting this curve was to review information at spaced out intervals. And that, right there, is the science behind why cramming for a test is almost never a good long-term strategy.
Okay, so this all begs the question, why? If our brains are working so hard to store information, why do we lose it so quickly? Let's dig into the main culprits behind all this memory loss.
So psychologists point to a few key reasons. We've got ineffective encoding. That's like when we weren't really listening to someone's name. There's simple decay, where memory traces just kind of fade over time. And yeah, sometimes we're even motivated to forget. But two of the biggest culprits, the ones we run into every day, are interference and retrieval failure.
Interference is just when other memories get in the way. And there are two main types. Retroactive interference, that's when new information messes up old information. Like when studying for today's class makes you all fuzzy on what you learned yesterday. Then, proactive interference is the opposite. Old information gets in the way of the new. That's like when your memory of your old phone number makes it almost impossible to remember your new one.
And then, oh my gosh, there's retrieval failure. This is that incredibly frustrating tip of the tongue feeling. You know the memory is in there, you can feel it, but you just can't access it. It's not gone, it's just temporarily unreachable because you're missing the right little clue to pull it out of storage.
And finally, there's this really fascinating idea of motivated forgetting. This theory suggests that sometimes we forget things because, on some level, either conscious or unconscious, we just don't want to remember them. Our minds might actually push away traumatic or unpleasant memories in a process called suppression or repression, basically to protect us. Which really brings us to our final lingering question. When we forget something, is that information just deleted from our brain forever? Or is it maybe just inaccessible, lying dormant somewhere, just waiting for the right cue to bring it back to the surface? The science of memory really shows us what a dynamic, flawed, and deeply human process it is, and it leaves us wondering just how much of our past is truly lost.